Business. Show business is our life, gentlemen. Hey, these guys on the screen with me also remember 6 years ago, folk, gathering in my radio studio to talk cosmology for about an hour, but that was every 2 weeks back then, and you couldn't show pictures on radio. So after I retired, my name was Baron back then on the radio. I now go by my real name, Ronnie Heron. We decided we couldn't stop. We had to keep doing this, so we're on YouTube with a vlog instead for our long time dedicated Astro Club, our telescope gathering group, the Santa Barbara Astronomical Unit. It's called the SBAU Astro Hour, and we're well into our 6th year with pictures, a lot of them with color, a lot of them moving. This is Astro Hour number 280, everybody, from Monday, July 6th through Sunday, the 12th. We're online at sbau.org, at least our club is, and at the Museum of Natural History in Santa Barbara. We're there Sunday afternoons looking at solar prominences. First Monday of every month, we meet in Farron Hall for our meeting. A week
First Friday.
later, what? What did I
First
do?
Friday, you said Monday.
Oh, you're right. I knew I wouldn't get through this, but that's all right. I got too much to talk about, but thank you for correcting me.
No wonder I'm always a week off.
Well, this show is going to go until we get so old, I'm not sure. We'll be stuck in our living rooms here without moving anywhere else. Well, here are some of the celestial topics. Up-to-date planetary boundaries and roundups and Mars, Venus, and Doug, since we're clean-cut guys that won't say Uranus anymore. Going to visit our handy-dandy Hertzsprung-Russell diagram this week to chart just how stars' surface temperature and luminosity change, and do some star hopping using Ursa Major, in case you happen to not know how to find the North Star, one of the most popular galaxy pairs in the night sky, M81 and M82. Finally, in honor of the past weekend, we're going to check our NGC 6946, the fireworks galaxy. So welcome aboard. Here's the man behind the talking points in his little den cave, SBAU President Jerry Wilson, man in charge.
Good morning, everybody. Good morning to my sister Joyce and my grandkids Calvin and Riley.
And your wife, Pat.
And my wife, Patricia.
She is so lovely. I'm glad she's coming to all the meetings. And she's a supporter of mine. And I guess you even followed Dr. Alana on Friday night, didn't she? On all that 800-year-old astronomy.
Yeah.
I guess she got into it. Here's our club's world-class outreach coordinator with his own ancient meteorite to prove it, Chuck McPartland. How are you, Chuck?
Can't complain.
Where are we going to be next?
Where are we going to be next? Friday at Refugio.
Okay.
And then Saturday at the museum.
That's right. Unless you're going to send out one of those devastating cancellations again.
Yeah, well.
It's the time of the year. He's also married to a Pat who doubles up as our merchandise manager and an incredible treasurer. Former Westmont guy, Professor Tom Whittemore.
Morning.
On screen. He is married to the lovely Maureen, and he's now a bread baking, bird watching bard of the Big Bang. Ladies and gentlemen, working on starting his speech career as a speaker, starting in December, is our lens expert, Tim Crawford. He's married to Karen.
Hello.
Okay, and you guys we're thinking about showing you some pictures eventually of what you guys see through the scopes on the Sunday afternoon crowd with only the sun to watch. But man, there's a lot going on up there. Sundays at the museum, aren't there?
Yeah, we can also, there's a website, speshweather.com, which is really fabulous because on the left column of that website, it shows you, first of all, above, it shows you the sunspots for the day. And then below, it'll give you a really good idea of what the prominences you're going to be seeing that day are. And we'll try to get something up here for you, but we'll have to work on it a bit.
I'm imagining everything you see is in suspended animation. It's not moving like they show.
No,
with speeded up. It's just too much distance.
Yeah, Ronnie, something David mentioned yesterday. So it was just David and me because Tim was not feeling so well. But what David wants to do, so what we have with the little hydrogen alpha telescope, we have the sun basically overexposed, okay, so that folks can see the edges. And so David's trying to come up with a scheme where he does a false eclipse by using colors on the SharpCap software. And it's not literally to knock out the sun, but rather to make it colorized black. So all you're seeing is the rim. It's really neat. And so he's trying to figure out how to do that. And maybe Chuck, you know how to do something like that with SharpCap.
No, I've
Yeah.
never used it.
Yeah, so they've done really great. He's done a really great job with Isla and folks in the observatory about colorizing the sun and things like that and the white light. But he wants to go for the hydrogen alpha. So
Yeah.
you get all the fuzzies on the edge of the sun. And yesterday
Sure.
the sun was really busy. It looked like it had a mohawk.
Yeah, to get both of those with a still camera, you have to really take two pictures. One exposed for the ball of the sun and the other exposed for the edge.
Yeah.
Yes, so
Yeah.
Jerry, he's basically got this thing imaging through the hydrogen alpha to the tune of, I think, a tenth of a microsecond capture. It just says blam, 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 blam. And with that real fast capture, which you see a lot of times is disturbances in our atmosphere. It just flickers. It just kind of flickers.
Yeah.
Really interesting.
Yeah,
Oddly,
I hope he succeeds in that. That'll be very
Yeah,
dramatic.
that is really neat. And Jerry, if you know how to do stuff like that.
the guys in the work, the
No, I
guys in the
don't know how to
workshop
do
will.
it. I don't know how to do it in real time. I know how to do it afterwards on a
Afterwards,
computer.
yeah. Yeah, we want basically, kids who, can't scramble up a ladder to come in there, look at the screen and see this thing. It's just amazing. I mean, David tweaked it yesterday, the H alpha little telescope, only 40 millimeter, um, to really bring out details. And during the day, I was there for 2 hours. I saw structures just changing dramatically, over the course of those 2 hours. It's really neat.
Yeah. Bad
Sounds
one
like
for me to miss, but I had to.
You
But
would have liked it, Tim.
yeah, from what I saw on space weather, I knew it was going to be good.
Yeah,
With the disc overexposed like that, so it shows up white, it does kind of make some of the prominences a little harder to detect because
right.
it's so bright. But
And you
We
have
can
a bit
try.
long.
We
Yeah,
can
he-
bring this up on Tuesday night to some of the guys in the workshop, and they might have some really good ideas.
Yeah,
Yeah,
do that.
and the other thing is David often helps Mike on Mondays when he can. And so he could noodle with that on a Monday afternoon too,
Yep.
doing solar.
Well, we may have a new feature, by golly, on Monday mornings. We'll leave it up to the president who's out there and is now going to guide us into the silly part of our show. We like to start Monday morning with a little fun and invite you to join us. I'm going to throw this to Jerry. What's going on the space station there?
Oh, these are guys that are all suited up, ready to go outside. They're going to step out. Someone's still in the dressing room, and you can hear him muttering, "No matter what I wear, I'm cursed with visible panty lines."
well, actually, that's a mirror.
Yeah.
Oh,
yeah.
you're right. That is, yeah.
Yeah,
Good catch.
And that's a lady astronaut.
yeah,
And then down here, it says, "Count yourself lucky. I've got a wedgie."
yeah.
What does the walk mean on the left side? What's the name of the cartoon?
I guess
That's
No,
the
this
name of the
guy.
cartoon.
Yeah.
yeah.
Rhymes with orange up in the upper right. Okay. Somebody else want to take this one on, Chuck? What are we looking at here?
Okay, well, I got a picture of the Earth with a crosshairs on it, and it says, dire news, an asteroid is on course to hit the Earth exactly opposite the Yucatan Peninsula, bringing back the dinosaur.
Pretty good.
You know what that reminded me of? That stupid scene in the first Superman movie with the late Christopher Reeve when he decided to save Lois Lane by flying around the Earth the opposite direction and it stopped
Yeah.
our turn.
Yeah.
Okay, I'm going to have Tom Whittemore translate. I haven't seen this one. What I
No, I
think.
put two in there last night.
Okay, yeah, this is a new one for me. It says, I'm not sure what that bubble up on the left is, but he
Well,
says,
that's where someone blocked something out.
oh, okay.
Is this a gnome or a?
No,
kind of
this is from an underground comic in the 60s. This
Yeah.
character is Mr. Natural.
Okay, the whole universe is completely insane. Yeah.
And I think Einstein would have agreed with that.
That's
Yeah.
right. God plays dice. Okay, Tim Crawford,
You
you want
know,
to take?
I don't get this one. I mean, there's a meteorite flying over a dinosaur, and the dinosaur or
Well,
something on the ground says, "Whoa, a meteorite."
Yeah, he just found one on the
he
ground.
just found one.
And he
Yeah.
doesn't
Oh,
notice the one that's about to hit him.
Yeah.
And it looks older than dirt.
Yeah.
Okay, now I get it.
Me too. And the big one overhead is the one that's wiping them out
Yeah,
65 million years.
yeah.
Yeah.
Okay,
Somewhere
right.
on Facebook, someone asked, "What's the oldest thing on Earth?" And one guy responded and he said, "Dirt. There's nothing older than dirt." Well, I showed a photograph of the meteorite, the nickel iron meteorite that you show. And I said, "This is older than dirt."
Yeah.
They need dirt on Mars. All right, these appear to be a couple of stick figure aliens. You're going to have to, I can barely see it. It's a little washed out, Jerry. So you can just read what's in the talk bubble on that, or you're going to reload it.
Yeah,
We can
I
all
think
read
I
it.
can do that.
Yeah.
They're silly science cartoons,
Yeah, I think this is a good one.
feature of every one of our talk shows on Monday morning
Mhm.
to get us in a good mood. There he
No,
is,
wait a
Professor.
second. I'm stumbling over my own brain.
Boy, I know what you're saying.
So glad you do too, Professor. The man who's never called doctor. Okay,
Ah, there it is.
there it is. You got it. And we're comparing pictures from the Carl Sagan's
Yeah, that's a good one.
etched disc on the Voyager, right?
Yeah,
Right. That's from the Voyager.
Somebody found it. What are they saying? Nah, it can't be.
it can't be them.
Yeah.
I'm looking at this guy.
That's pretty good.
Oh, Lord. Okay.
I didn't
Yeah.
get this one.
Oh, yeah, that's where we're going.
Night
I don't
sky
remember
circa
this one.
2030.
Yeah.
What's
Is it
that point of light that doesn't move?
Yeah.
Elon's up to almost 11,000 now with the
Yeah.
latest launch, and it's brightened the sky over the entire Earth by 3% already with
Yeah.
Wow.
satellites.
Wow.
Have you guys been hearing the launches? I haven't.
Oh, I hear them occasionally, but yeah, we hear the rumble after they go by.
Right.
And
Yeah.
that's about 5 minutes after the rocket goes over our place.
Mhm.
Yeah, I haven't been hearing the sonic booms as much.
Well, that's only when they come back, when the booster comes back, you hear the sonic boom.
But
I
but
think.
these orbiting satellites that he's putting up, are they sort of like mobile cell phone towers?
Yeah.
Yep.
Yeah.
Exactly what they are.
But they're a couple hundred miles away or 100 miles away.
But they deal in data, not sound.
Well,
Right.
sound is data.
Yeah.
Is it really? Okay.
But due to the active sun, he's losing 10 or 15% of these things a year, and he has to keep putting new ones up.
Oh, there's 10 or 15 a month that come down.
Yeah.
Wow.
Okay.
Is each and every one of them fitted with little retro rockets to put them in the right orbit? Every one of them?
They have slight attitude or
They have little
control
thrusters, electromagnetic thrusters.
yeah.
Okay. Mr. Whittemore, can you make sense of this one?
Yeah, so kid's taking his first steps. Looks like on the moon. It says
Well,
Olivia Little Fabian just took his first step for mankind.
that's right. One giant leap.
He's doing the best he can.
Yeah.
Oh my God.
This
Who's
is a
Elon?
sneak. This is
One
a
of you
sneak
two gentlemen that
preview
own
of.
Tesla. Go ahead.
This is a sneak preview of Tesla's new bus.
Yeah.
Which Star Wars movie was this from?
The first one.
Really? I don't recall. Well, maybe so. All right. But it's got Tesla on the side. I didn't recall them being brown, but maybe they were in the color movie. Okay, got us in a silly mood, so let's talk about fireworks galaxy, among other things. We'll start with the roundup in the night sky, everybody. Here it comes. Brace yourself. The screen is going to be flooded with the night sky. There it is.
Okay, this is the planet.
morning.
What?
That's the morning sky.
Yeah.
Yeah, Ron said the night sky.
Looks
Oh,
the same to me. I'm
well,
sorry.
it's still night.
I just know the
So this is
horizon
a
is the
show
wrong
of
shape.
what the planets are in the morning sky for today.
Mhm.
And this was about 6 or 4 a.m. this morning. So you missed the moon position. It's now a little farther than it was. Saturn was there. These red things are asteroids, which I haven't gone to the trouble of naming.
Mhm.
And then down here we have Mars, Uranus, and Saturn, I said that, and Neptune. So that's what's in the morning sky.
Mhm.
Hmm.
So the Pleiades coming up ahead of the sun.
Yeah.
Okay, I'm gonna.
Already on their way back.
Yeah.
And Doug is out there somewhere in the middle of all of it.
Yeah.
Next to Mars.
Do you get to show the evening, Jerry?
Yeah, we're getting
Yeah.
to it.
Okay.
Whoops.
So this is a very clever picture. It shows Mars there and Uranus there.
Well,
Take
wait,
a-
Uranus is off to the left.
Oh, is that off to the
Yeah.
left?
Yeah.
Okay. Mars and Uranus.
And you're incredible, Chuck.
It does look a little blue.
And this picture was taken through a field of oatmeal or what?
At least through one plant without leaves.
Mhm.
Okay.
And that's a 10-year-old photo, actually, according to the caption.
Yeah. Okay. Now this is the evening sky.
Yeah.
Mercury is down here this evening. This is 8 o'clock at night, and it is still light. You can see the
Yeah.
sun is just down here.
Yeah.
It's
Mercury's
black.
a washout. It's a washout, Jerry.
Yeah.
Even
Really.
Jupiter's
You can't
tough.
see it.
Even Jupiter's really hard. The sun is technically right in the belly buttons of Gemini, right in the belly button.
Okay. So you mean Jupiter in the sky is hard, not on this chart.
Right, right.
It's really tough. Yeah, it really is tough. Venus is no trouble.
Yeah, Venus is really striking and quite high.
It's
Yeah.
moving up towards Regulus, so you can kind of watch it every night.
Yeah.
Moving up.
Regulus is right there. And I don't think there's any other planet. No.
Oh, that's it.
That's it. Yeah.
Really? There's no Lucy in the sky with diamonds up there?
You don't need the sky to see Lucy in the sky with
Oh,
diamonds.
that's right. Oh, you do it. The mushrooms will do it.
Yeah. So last week I started talking about this and then I stopped talking about it because I realized I didn't know enough detail about it. But it's about the evolution of stars and the Hertzsprung-Russell diagram. And this is a very nice copy of a Hertzsprung-Russell diagram. It shows luminosity over here. And this was first developed, the seeds of this were developed in the 1890s, 1900s by the Harvard calculators or computers, I guess they call them,
Yeah. Mhm.
ladies. And here is the color. So they identified what the color of a star is with its surface temperature. And so this is blue minus violet color.
Mhm.
And but this is going toward the red. Obviously, you can tell because it's down here on the red stars, and red is cooler. It's just like a blacksmith hammering on a piece of iron in his forge. You start out, get it hot, and you start glowing red hot, and then it passes up to yellow hot, and then if it keeps going, it'll go up to actually white hot. And those are the higher temperatures. When you put a star on this plot, it's in a certain kind of a family. It does not traverse the whole chart. It doesn't go up here for a while and then go down there for a while. And it's very misleading because it looks like people try to look at this as if it were an evolution chart. You can do evolution on it, but it's not what you might think without proper instruction. So we'll see what we can do here. Now, this is a Hertzsprung-Russell diagram before the what you see there. When you are on this chart, this is stars that have fusion, for the most part, have fusion going on in their core, except for the white dwarfs down here, which don't have fusion going on in the core. But this is an end stage where they've run out of fuel. And so now they're just coasting, and they're very hot. It's going to take them a long time to cool down, but they're just hot globs left over from nuclear fusion. But before nuclear fusion, they start collapsing under their own weight. And everything about a star is determined by its mass. What it's going to become and how long it's going to be that and what it's going to end up as is determined by the clump of matter you're given at the factory to make the star out of. So this shows, these lines show the time period that stars are in this stage. And these are stars that are lightweight stars down here, and they drop down in straight lines to get onto the zero curve here, which is the start of the Hertzsprung-Russell diagram. This is called the main sequence.
So they start fusion when they reach down there, or that's where they settle as they're doing fusion.
Yes, that is right.
Sometimes called zero age.
Yeah.
Yes, that's what I was struggling with.
So Jerry, ZAMS, Z-A-M-S, zero age main sequence, ZAMS.
Okay.
But they heat up.
That's why I used to teach it anyway.
They heat up, and so they do have luminosity even before they start the fusion.
Yes, good point. As a matter of fact, an example of that in our solar system is Jupiter. Jupiter has a certain mass, it's much more than the Earth, and Jupiter has started collapsing or had started collapsing under its own weight, and that generates heat. Just when you compress things, just like a diesel engine, you compress them really fast, and then it'll produce, in a diesel engine, it'll produce enough energy to ignite the fuel in there. So you don't need a spark plug.
Right. Just a little note, Jerry, on the vertical axis, everything's compared to our sun, and it's logarithmic. So anytime you go up a notch, you go power of 10. Anytime you go down a notch, you go down by a power of 10.
If you would do it in a linear scale, this chart would be very tall.
It would be tough to read.
Yeah.
Well, are red dwarfs or even brown dwarfs unlit stars on this scale anywhere?
The dwarf end is down here. These are this is a star here at 1. This is the solar mass.
Okay, got it.
So that blue line is the sun's evolutionary track as it started up.
Right there, yeah. This one here, it falls down this way, then it goes up this way in its luminosity, and there all of a sudden it turns on. Its hydrogen core ignites.
Right.
So they're up here, the heavy ones, they tend to come in on these kind of shaped curves. The lighter mass one tend to fall down here, so their luminosity
actually drops.
Drops as they get down, and then all of a sudden it heats up. But they're not going to go very far. So there's two guys that developed this theory, the Hayashi track and the Henye track for radiative transport. The Henye track is for masses less than half the solar mass. So that would be half the solar mass would be right here. And these are the ones that drop straight down. This was theoretically modeled and predicted by Henye. And then up here, they were predicted by Hayashi, who calculated these things. And this is what it was looked like. And this is borne out by observation.
And those Henye red stars there that drop straight down, you can see they're actually brighter when they're just forming and getting their energy from collapse than they are when they're doing the fusion.
Yes.
Why is that, Chuck?
it's just the energy that's released as they collapse.
This is surface luminosity. This is the thing that involves the turn on of fusion is core temperature. So it may not shine very bright, but it's got a hell of a lot of temperature in the core.
Right.
So you get a decouple between apparent luminosity and the energy involved in starting the star's fusion. Now this one is the solar, our sun. As just before, this is cooler and blue is hotter. And this is its pre-main sequence. Now, these pre-main sequences are not shown on the HR diagram. That's only what they call adult stars, not pre-main sequence and not post-main sequence. So this is the zero age main sequence, and that means where they enter. So the sun's zero age, that's when it starts being the sun as we know it. And it'll last about 5 billion years total.
And Tim, you can see the luminosity is higher up there when it's first forming, but look at the radius, 100 times the radius of the sun. So it's got much more surface area that's radiating light, even though it's cooler. So that's why it has more luminosity.
And so this is where it is in a protostellar
cloud.
Yeah, protostellar cloud. Thanks. Yeah, the ring around what's going to be the star.
Oh, okay. There, I got it. I just saw the radius. I was looking for the radius there. Now I got it.
There, yeah. There's one solar radius right there.
Okay.
So pre-main sequence evolution. Pre-main means the beginning before
it's a star. Yeah. And we see things like these in the Orion Nebula. We see Bok globules. This would be one of those things, for example.
Oh.
Bok globules we see in the Orion Nebula are black, but at some point they're going to start glowing with their own compression heat, but no fusion yet.
Well, this is just fabulous. This has always confused me. The HR diagram always confused me.
Now the main sequence.
For some reason it's going right to left. Why would it be going that direction?
Well,
that's just telling you that it's getting hotter.
Yeah, the temperature.
As it collapses, it's under 3,000 degrees. Here, it's at 5,800 degrees Kelvin. The sun right now, the surface of the sun, its photosphere is 5,800 degrees Kelvin. But when it first starts collapsing, it's less than 3,000.
And I don't like the way they place the radius there, because if that were really the track of the sun, then the one solar radius should be right where it intersects with the main sequence at that triangle.
That is where it is.
No, that seems to say 10 radii.
Oh, you mean across there? Oh,
Yeah.
This is a parameter that covers each of these lines.
Yeah.
This is not a vertical scale. This is one radius here, this line.
Okay. That line must be washed out in that presentation there.
Oh.
Yeah, okay. Yeah, in the talking points, I can see that there's a dotted line there showing that. Okay, that makes more sense.
Okay, let me get back. Doodah.
One of my favorite songs.
You know, those videos you can see on YouTube that show the different sizes.
Oh, wow, there it is.
And we have our sun is a speck of sand versus a beach ball. And they have giant, these giants. You wonder, they're all on this scale somehow, aren't they?
Yeah.
This way of displaying it shows more detail, but it doesn't honor how I've sequenced them. So we'll show one or two and then it won't do anymore.
Wow.
Okay, now this one, which benefits from this shows the other one was for the sun, and that's here at one solar mass, comes down here and chunk down there, just under 6,000 Kelvin. But this shows all the stars, all the types of stars, up to very massive 100 solar mass stars. They come in as they compress and their temperature rises, their luminosity rises too. Here, the temperature does not rise so much, but the luminosity drops.
Really?
Because they have much bigger radii, so they have more area that's giving off light. That's why they have more luminosity, even though they're lower temperature. That's why Betelgeuse, for example, is really bright, because it's got a huge surface area, even though it's cooler than the sun.
Yes.
Mm.
Okay. Now this shows the sun's post main sequence. This is the background is the Hertzsprung-Russell diagram showing the different regions where different types of stars live. But in this one, the sun here is going to shift from hydrogen to helium burning, and it's going to go up here to a, oh God, I forgot RGB because it looks like red, blue, green, blue, but it's
Giant branch.
yeah, it's the red giant. That's it, red giant branch. Thank you. And then it's going to travel up here, and it's going to do what's called a helium flash, and then it's going to burn helium. The helium burns to carbon and oxygen, and when it does that, it's briefly in this giant phase. That's when it's going to grow and possibly consume the Earth, although it's still not determined whether it's going to consume the Earth or through solar wind, it's going to lose so much mass that by that time it won't have enough mass to contain the Earth in its present orbit, and the Earth will expand its orbit to stay ahead of the sun. Sun's expansion, so you don't know. So then it's going to, yeah.
So this part hasn't happened yet?
No, we're right here. This is real time now. It's
Ron, if that happened, we'd be in big trouble.
Yeah.
Oh, wow.
It would, the Earth will not be habitable by the time it leaves the main sequence.
Even at the very beginning of that, when it starts traveling upward, that's bad news.
Yeah.
So planets don't even survive to the point of making iron where they blow up.
Some planets can survive if they're far enough out. Some planets just get ripped apart. And that's what we find in asteroids, for example. I don't think our asteroids are solar ripped apart planets, but they're collisional ripped apart.
One more aspect that's kind of interesting is that as evolution goes, we might evolve as it goes through these stages to become a different animal.
Yeah.
When all the water boils off and the atmosphere is gone, you ain't going to have any animals hanging around.
Unless we change our chemistry to asbestos.
Yeah.
Yeah.
So then you get up here.
There's also a possibility of some nitrogen, the CNO cycle on that giant branch, the CNO. Yeah.
Yeah, all the details are not here. These are just
okay.
features. So then you get up here into the supergiant, and that's where it starts throwing off outer layers, and it goes through the planetary nebula stage up here. And then
it's forming it.
Yes, it's forming the planetary nebulas. And once it does that, it's thrown off its outer layers, then it cools rapidly and contracts to a white dwarf. And the fusion is not operating anymore. So this is just a big ball of whatever is left over, nuclei, and it is cooling off. And it's just taking a long time to cool off and go through the white dwarf stages. And here we have Sirius B, the little pup from Sirius A, and we have Procyon B down here that are in this white dwarf stage, and the core of the Ring Nebula is in this white dwarf stage.
I didn't realize that fusion in white dwarfs, that a fusion wasn't going on. I didn't realize that.
Yeah, they're just embers.
Yeah,
but they're still really hot, though, right?
A big cinder.
It's the night after you had a campfire, the morning after, and there's just embers down there.
Yeah, and notice, Ron, that the sun spectral class goes from a G-type star out to an A. See that? So more in the blue. It's more in the blue.
I'm barely hanging on here, gentlemen. I'm willing to admit.
Well, this is a considerable detail. This is pretty good.
Well, here's the basic thing I don't understand. All the jillions and jillions of stars, or at least most of them, are going through this. They're throwing off stuff. where does it end up? I know the light, which is not matter, becomes what we see in our telescopes from 13 billion miles away. But what about the protons and the solid stuff?
They're
Where,
just out there.
it's just everybody, all the stars is matter is going by each other and intermixing and
Well, the space is mostly empty, Ron.
Ron, this takes a long time. This takes a long time for this, this stellar evolution. And by the time, the sun is down there near Procyon B, okay, it's an A-type star and it's probably glowing at 100,000 kelvins. It used to be about 15 million, you know. The sun right now in its middle is about 15 million kelvins. So it's considerably cooled down. And like Chuck said, it's just an ember, you know.
but I was concerned about the stuff that gets thrown off. Does it end up in nebulae? Does it
Yeah,
slow down and get?
Yeah,
Yeah.
making new stuff.
Yeah,
Okay, got it.
it's just like smoke rising off a campfire. It goes
Where
up
does it
in the
go?
air
Yeah.
and
And
distributes out.
so the white dwarf is very, very super dense.
Yes,
Yes,
A
yes.
teaspoon would weigh tons. So that you literally have a teaspoon of tons just cooling down and it's going to slowly just kind of dim out.
it'll
Yeah.
dim out and become
Yes,
a
yeah.
black star, a dark star.
Black dwarf
Yeah.
eventually.
Black
It'll
But
be
dwarf,
a
yeah.
major owie if you run into it in your spaceship.
the
Yeah.
universe hasn't had time for any of those to form yet, we don't
But
think.
that's a long way off.
Yeah, and Tim, the magnitude has dropped like 20 orders of magnitude, you know?
Does this have any correlation to dark matter?
No.
No,
Think
no.
about dark matter here.
But are white dwarfs and red dwarfs, even though they're totally different stars, are they about the same size?
They're down here. The red dwarf branch is down here.
Mhm.
Okay,
Um,
But the
and
radius is still much larger for a red dwarf star. They're not planet-sized.
but there's not as much stuff.
Right.
Not as much
these are
matter.
very compact. These
Okay,
are not so compact.
Yeah.
Oh, okay.
Yeah, red dwarf stars are kind of a little bit fluffy, but white dwarfs aren't. White dwarfs are very tough.
well, I've heard that they can't really think there's life around red dwarfs because too much is going on.
Well, they're active in flares and X-rays, yeah.
More so than a white dwarf?
Well, a white dwarf is just super, super hot. You're not going to
Yeah.
find any life close into those either.
No.
Because there's more matter in them.
There's no fusion energy trying to get out. It's just conducting out to the surface and then blowing off.
Mhm.
Hmm.
Okay. This is the close-up of the core region for a one solar mass asymptotic giant branch star. Now that's when it's up here. This is
So it's using
asymptotic-
helium.
asymptotic giant branch. So it's above here, it's going up through this, heading for planetary. And this is the helium layer. This is a helium burning shell. It's switched over to helium burning. And this is the carbon oxygen core left over from the previous stage. It's
Or,
no
or
fusion.
being added to by the current stage.
Yes.
Yeah.
And this is the hydrogen burning shell on the outside. It's shrinking.
This is the one in the talking points that I just didn't get at all, but now as you're explaining it, I'm starting to get it.
Okay.
This
So
is where
this
it
is-
starts the helium cycle, right?
The helium cycle has been going a while to
Yeah.
have this carbon oxygen core.
Okay.
So this is getting ready to become a white dwarf with this non-fusing core.
And the
This-
actual size of the star is much, much larger. This is just the core.
Yeah, this is just core. The actual star is over here. Radius is equal in the range of 1 to 1.5 AU. So this star would, in all of this range, would hit the Earth's orbit if the Earth's orbit stays the same.
That's the size of our sun.
No,
Yeah.
no.
No,
This
this
is the
That,
size
that's
of our sun.
that's the size it would be. It will be when it goes into this AGB stage.
Yeah.
Oh,
Much larger, reaching out, to the asteroid belt.
and why does it stop fusing?
Well, it hasn't stopped fusing here, but
No.
it will when it runs out of the
fuel.
The helium.
Really?
Yeah.
Well, I thought it went through steps up the
No.
If it can, it will, but it needs more fuel to go higher, more steps,
More mass. Yeah.
more mass to
Well,
cause, because the triggering thing that starts fusion at any layer is mass. And
sure.
when like when our sun runs out of hydrogen and it starts burning helium, it's because the outgoing energy has decreased, so the incoming compression starts again, and it boosts the core temperature to high enough to burn helium.
But with our sun, because of the limit of mass, it never gets enough temperature and pressure in the core to fuse this carbon and oxygen.
Right.
And that's as far as it goes on the periodic table. Up
Yes.
to what, 8 or 9 or 10 among the elements? It
Yes.
never gets
Carbon and oxygen. Maybe
Yeah.
some
That's it.
nitrogen.
Well, I'm
Only
starting to get this.
Oxygen is 8 and carbon is 6.
6 and nitrogen 7.
Yeah.
So it never even hits 10. Wow.
So with more mass, it's going to be able to burn that core.
Yes.
Or faster.
Okay, now I'm
and it'll
starting to
burn
get it
higher
here.
other elements too.
Okay.
We get the-
And not only do you burn more, but like Jerry says, you burn faster. So that's why you live fast and die young if you're massive.
Yeah.
So we get the higher elements on the table from the giants.
From the
And
more
from-
massive stars.
And from explosions, supernova. So you've got gold and platinum from supernovas or kilonovas, I guess it is.
Oh, that's almost what, instantaneous creation?
It's pretty quick.
Mm-hmm.
Now, the previous one we showed was just the sun and its life cycle past the main sequence and up here. But now we have other ones that we're looking at. Here's where you have
Nope, we're nothing on right now, Jerry.
There's no picture. There.
See it?
Now do.
Okay. So before we did just this branch here up to here, and we're going to stop that branch here because we're looking at other stars that start out much more massive, and then they become supergiants too. 5 solar mass here does hydrogen to helium burning, and then it goes up to helium, carbon plus oxygen. So does the sun. So does this one. But these are much bigger stars, and they have higher luminosities. They're emitting much more magnitude or much more energy.
Huh.
They go through a similar thing. They will not all cycle down to planetary nebulas. Things this big are going to blow their tops. They're going to become novas
Supernovas.
and supernovas.
Is the cutoff for that the five solar masses?
I don't recall the cutoff.
I think for supernova, it's like 8 to 12.
8 to 12.
Where you leave a neutron star, and above 12, you probably will leave a black hole.
Oh, wow. Okay.
So my question, more than half the stars out there, at least binary systems, right?
Yeah.
Does that affect, does things change if they get
And the
too
bulk
close?
of them are all red dwarfs.
Yeah.
Most
But
of
that
them are red.
complicates things. Yes, they can interact with each other.
Yes,
That's where you get novas generally, is where they interact.
yes.
Or collide?
Yeah.
They ever-
And then if they collide, that can be supernova.
Yeah,
And
these are we're getting more complicated, but in simplistic, we're taking single stars as they go unbiased, no
Yeah.
dating. So this is the internal shell structure of a supergiant on its last day before it novas.
Yeah, a massive supergiant.
Yes. So, and there you have the ugly iron core. And because that's iron, the fusion stops. So you have a silicon sulfur shell, a carbon oxygen shell, a helium shell, and a hydrogen shell. And
Wow.
And then a bloated hydrogen atmosphere way outside of that.
yeah, because this is just the core region.
And that's silicon, and what's the other one?
Sulfur.
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 And now because the core is not fusing, because it's iron, the whole thing stops. The energy does not go out, and the whole thing collapses on itself and then bounces off of itself and nova.
Supernova.
Okay. Now, so that's what's hidden behind the Hertzsprung-Russell diagram. Now we're going to do, I found this neat set of graphics here that show
These are great hops, Jerry.
star hopping. Yeah. And you start with the easiest constellation in the sky, the Big Dipper. And these two, the pointer stars, point directly to the pole star. This is second magnitude star. So from our city here, it's not always that easy to discern which one it is, if you're really disoriented, which I usually am.
Me too.
Another one that I learned from Chuck was you take the curved handle of the Big Dipper and you just continue to curve it on around, and it comes to the arc of these stars comes to Arcturus.
Yeah, arc to Arcturus.
Yeah, and this they continue arcing around to Spica.
Spike onto Spica.
Yeah. Okay, then the two top stars of the Dipper, they point to Capella.
Oh, I never knew that one.
Huh.
This one, the back two stars here, they point down to Regulus.
That's a really good one.
The right
I didn't know that one either.
What's
That's
that?
a good one.
I didn't
It's a
know
really
either
good one,
of those
Jerry.
facts.
I always tell people in the planetarium, poke a hole in the bottom of the Big Dipper and the water runs out on the lion.
Okay. Yes, I've heard that.
I've never heard that either.
Now here, you can take right through three stars in a line, and you go right down here to Castor. And that's a small jump to Pollux.
And is
I
this
didn't-
how the sky would have
These are
looked like?
great hops.
Is this
Yeah.
how the sky would have looked like to the Mayans 800 years ago?
Yep.
Oh, yeah.
The sky to the Mayans without city lights and no clouds, it would have been just dramatic. You wouldn't have trouble seeing to 6 magnitude, let alone second.
But according to our Friday night speaker, the only thing they saved on the wall and those chips on the rock plates was the eclipses. You'd think Orion's belt. I doubt
Well,
they
had stories about the constellations. They just didn't put them in their
They didn't put them
their
up
monuments.
You know, they had, and he alluded to this, but he didn't specifically cover it. They kept good written records, and they had libraries full of books. And they worshiped, their god was Quetzalcoatl, which is the snake. And when the conquistadors came over, the priests with them realized that these were devil worshippers. And they went through methodically and they burned every single book and document they could find. So it's the worst case scenario of the fire of the Great Library of Alexandria. And it's just unforgivable that all that knowledge was lost. But one guy kept something hidden, and that was the now known as the Dresden Codex.
I think there are 3 or 4 codices that partially survived.
Okay, there may be.
The Dresden, I think, is the one that's most complete.
Yeah.
Yeah, they had stories. They had the 3 stars in the belt of Orion were called the hearthstones of creation, and Orion was a large turtle, and the hearthstones were on its back. And Castor and Pollux were the eyes of the owl, and they had a frog, and they had a snake, and they had all kinds of constellations. Seven Macaw was the Big Dipper.
But you're talking papyrus here in Europe, right? They only use
No. This is the Mayans had bark paper that they made, but
they have wood planks they wrote on.
Oh, I didn't know that. I didn't get that impression.
Yeah, he showed pictures of the Dresden Codex.
Oh,
They had numbers and letters all over the place. So
I did ask the gentleman, was it only solar eclipses? And he did answer me, but I swear I don't remember how did they ever.
No, I don't think they're completely sure about what's being said in there at all.
yeah.
So,
But they did keep track of solar and lunar eclipses, and they predicted them.
and the position of Venus.
Yeah, Venus was really important to them
Yes.
because it
It's
was part of their
logical that they would.
agricultural cycle.
Tom and Tim, they would depict two parts of the same carving, one a dark sun and the other a light sun, meaning it goes dark.
Yeah.
Amazing.
I don't know
Well,
what
it was a snake eating the sun type picture that they
Well, that's true,
put
but
in.
I got a darkness out of one
Yeah.
side of it anyway.
So they picked, as we learned last Friday night, they picked a 20 base number system because we have 20 digits, 10 10 fingers and 10 toes. We somehow got stuck on our fingers only, and we have a 10 base digit system.
Well, see, they weren't wearing shoes.
That's
Tim, you would love that. One line means 5, and 2 lines means 10, and then 3 dots over those 2 lines is 13.
Yeah.
And I figured that out right away. He didn't really say that. It had to be based on
No.
our hands.
He said that. No, and they based it on base 20.
Oh, they did?
Yeah.
They had it in the toes.
Yep.
So we saw a bunch of star hops based on using the Big Dipper, but now within the Big Dipper, there's just a plethora of objects, mostly galaxies, and one of the best ones is M81, M82, which is you locate. Here's the Dipper out here. This is a double star, and it looks a little lopsided here. So you go out to this star, Dubhe, and you turn right 90 degrees. About this part of that length, you swing it south, and there's the 2 galaxies.
No, wait, that's M51. That's the whirlpool.
Oh, M51.
That is a pair of galaxies.
Yeah.
I thought you were referring to 81 and 82.
I was mistakenly because I can't read this.
Okay. That's
You're right, M51.
If you go across from the bottom left of the Big Dipper bowl to the upper right of the Big Dipper bowl, that kind of points to 81 and 82.
That's right.
Old man Messier just decided when he saw them both together, I'll give this one that number, and the next one will be its neighbor.
Well, those numbers were assigned later by the order in which they appeared in his catalog.
Yeah.
Jerry, you go to the lower left of the bottom of the Dipper.
Lower
left. And then go to the upper right one. And then equidistant out. And you're just about on top of M81 and 82.
Okay.
Now there's an arc of stars out there in a darker sky. And Joe Doyle told me one time, in a darker sky, there's a little tiny arc that kind of looks like the little red points.
Uh-huh.
And you just follow that arc, and it leads you right to M81, 82.
Okay.
And
So that's a good star hop. And this is a picture of M81 and M82,
Yep.
or vice versa. And this one has got we're looking edge on, and it's got an eruptive core. It's a very dramatic galaxy, makes excellent pictures. This is an amateur picture, I think. Yeah, I didn't give credit.
Can you guys see them this clear in your scopes?
No.
Not visually, you don't. You sort of look to you do averted vision, and you can tell that this is kind of long, fuzzy. That's why we call these faint fuzzies.
Yeah.
Because that's what they look like, faint fuzzy. You do not see any, in smaller scopes, you do not see any of this structure. In 20-inch scopes, you can, but very few people bring a 20-inch scope to the star.
And in M82, in the cigar there, you can see those dark lanes on a good night.
Yeah. Okay. Whoops.
Went backwards. Fascinating stuff. So when you say there's a hard going core to a galaxy, that means it's got a supermassive black hole with a very busy accretion disk.
And also M81 over there, the bigger one, is tidally disrupting M82. And so you get clouds of gas that are colliding with each other and causing a lot of supernovae.
They're that close, huh?
Yeah.
That's going to happen with us in Andromeda someday, maybe.
Yep.
But not for a few million. Well, it's 2 million light years away, or 2 million actual
It's 2.5 million light years away. It's
light
like
years.
4 to 9 billion years away for any potential collision.
You have to do the math to put it in terms of how many actual miles. We're talking
Yeah.
quadrillions of miles.
M40 there with the yellow circle is one of the worst things in Messier's catalog.
That one?
Yeah, it's like a little double star.
Double star.
He might have had a bad night.
Yep.
So there's a lot of things in here, like M51 out here. And that's
There it
this,
is.
the Whirlpool galaxy. It's interacting with this other galaxy over here. I don't know which one's taking stars from the other one, but I would say this one's winning.
Yeah. The other one's in the background.
Yeah.
They're not touching.
This is M101, the Whirlpool, or is that what it's called? Pinwheel.
Pinwheel, yeah.
Yeah.
It's right behind your head there. You just moved out of the way and showed it.
That's right, yeah. That's a picture I took.
All right, Jerry.
And
That had a supernova a couple of years ago that was visible in that lower left spiral arm.
oh, down here.
Yeah.
Wow.
This one is
Fireworks.
the fireworks galaxy, NGC 6946. And the reason it's called the fireworks galaxy, and it's in this discussion group here, is because it has the largest numbers of supernova that we've seen. Since 1917, it has produced 10 supernova. Compare that to the Milky Way's roughly 1 to 3 supernova every century. So this one has had 10 in the last century. So it's a real hothouse of exploding giant stars.
So that's why they call it the fireworks?
Yep.
And M82 has a lot too for its mass.
Yeah.
And I sent the explanation of this one in a caption, but I left it in Polish and untranslated for Tom's benefit.
Thank you. Dziękuję.
Now, I'm wondering, you didn't show it in this, you didn't play through it, but it's in the handout. Is Messier 109 the vacuum cleaner galaxy? I've never heard that one.
I didn't either.
Yeah.
I don't know why it's like that. It's a nice little barred spiral.
Yeah.
The reason I skipped over it is because I can't find it in there.
Yeah. It's probably just listed with its NGC number.
Yeah.
It probably is. And I've forgotten which one it is. I do these, I rehearse it like when I first make the charts up. And then I go, oh, that's obvious. I know that. I know that.
What is it? M09? 109?
109, yeah.
106 is over there, but 109.
Mhm.
By the way, the Owl Nebula here is a nice little planetary nebula just off of this star. Which one is Vecta?
Vecta, I think, is in the Little Dipper, isn't it? I don't know.
Yeah. Vecta, the bottom inner corner of the Big Dipper's bowl, closest to the handle. So I
Okay.
guess this is Vecta.
Okay.
So Jerry, if you make that picture just a little smaller, just a pinch smaller, there, you can see the 3 hops of the gazelle. Do you see the double?
It's 3992, Jerry.
Yeah, it's called the three leaps of the gazelle.
3992 is
On the bottom, Jerry, just hop, hop, hop.
Wait, I'm looking for the 3992.
Oh, okay.
I don't see that in there. Okay, now where's the hops?
Down on the bottom of the screen there. See the 2 and then 2 and then 2.
Oh, okay.
Three
oh,
leaps of the
how
gazelle.
darn.
It's actually 2 leaps and 3 landings.
Yeah, you'll see that in old almanacs, the 3 leaps of the
But
gazelle.
they refer to that.
Yeah.
Yeah, In Wikipedia, they call it the vacuum cleaner galaxy as well.
Huh.
Interesting.
Do they give a
Okay.
reason?
I haven't. I'm gonna check it out right now.
Is that also called Hoover 333?
Yeah.
Well, you suppose we'd be able to see more of these things on Saturday star parties if we had better seeing and less lights at the museum and less.
Definitely, darker skies would help.
Yeah.
Hmm.
And they'd be visible in the sea stars. It just depends on what tree gets in the way.
Yeah.
Yeah. Yeah.
Oh, I don't. Not that I see.
Okay. Maybe it looks like an old vacuum cleaner logo.
It's interesting. It just says or the vacuum cleaner galaxy.
Yeah. Maybe it's an Electrolux, not a Hoover.
Well, excuse us, folks. We're just having fun
Yeah.
checking the night sky here.
Those are really good vacuum cleaners. The Electrolux. I think they're Swedish, right, Chuck?
Oh, I don't know.
Yeah, I think they're Swedish. We
Huh.
had one, we had a used one when I was a little kid.
Well, gents, we've reached an hour.
Uh-oh.
That's okay. Maybe we'll bring you sun flares on Monday morning from the day before at the museum. Jerry,
So
got
just
anything to
back,
offer us? What?
Probably not flares, Ronnie, but prominences.
Oh,
Yeah.
it says the vacuum cleaner galaxies gets its nickname because of the prominent central bar structure and spiral arms act like a cosmic vacuum.
Really?
Not me.
still doesn't work for me.
Yeah.
Oh,
But the word main sequence is that central bar on the Hertzsprung-Russell diagram is because that's the main thing. That's what's happening. 90% of all stars in the universe are on the main sequence, including our sun.
Is that right?
And that's where they sit and do their magic until they start messing around with things other than hydrogen.
Yeah.
now Richard mentioned in the workshop that's when I asked the question, what does it mean? And he says it's the stars that are burning hydrogen to helium.
Yes,
Yeah.
that's right.
Yeah, that's right.
Is that correct?
Yes,
Yeah.
that's correct.
Mhm.
Okay.
Well, we got to visit this topic again, gentlemen, especially the part about making the new elements, because I'm trying to imagine a layer inside a star of 1,000 miles thick of all new helium or new carbon or whatever. And
You got to realize those conditions inside that star are very different than what you find here on Earth.
Well,
And also, it's just a case of what their density is.
Yeah,
I know, but I wonder how in the world you get full layers inside the Earth of the same stuff. Is it like that in the star when it
Yeah.
blows up? Doesn't it mix everything together?
Yep.
Yes, when it blows up.
I know, but how in the world do we get any, atoms are very, very tiny, and yet there's gazillions of them in
Remember,
layers.
there are no atoms in a star.
Right, right.
So it's all made afterwards.
Plus, it makes huge amounts relative to the size of the Earth. And so once they collect into a cloud and form into a body, they again coalesce to their density levels. And that's why they tend to collect again.
We'll put that on a future talking points, Jerry.
Okay.
And we're all
I
looking
think we've
forward.
covered it and we'll cover it again.
All right. We're looking forward to your speech on exoplanets, looking for other Earths. So we'll do it again next week. That'll be number 281. In the meantime, we'll see you at the Star Party Saturday night and somewhere Friday. Where's that going to be?
Refugio State Beach.
Refugio. Come on out and support our
Okay.
guys.